Good morning, good afternoon, and good evening. Thank you for joining us for today's IBM Tech Exchange webinar. I'd just like to go over a couple of housekeeping things before we begin. You should see a Q&A box towards the bottom of your screen where you can begin to submit any questions that you have for today's presenters. Later today, you'll be sent a link to the on-demand recording, a link to access the slides, and a link to the IBM Tech Exchange community where you can connect directly with our experts. So without further ado, I will hand it over to today's presenters.
Great. Thanks for the introduction. Folks, I'm Brian Promise with IBM's software networking team. You're joined today by Tom Griffin and Alec Gartowski. Between the three of us, we're going to be walking through a series of concepts and live demos to help you understand better, how to future-proof your network management while you're navigating the challenges of moving to hybrid cloud and dealing with modern IT demands. In this session, as just stated, if you have questions at any point in time, please jump in the Q&A. We'll be there monitoring it live, and we'll absolutely interrupt the content to make sure that you have the context that you need and your answer is given back to you. So without any further delay, Tom, I turn things over to you and introduce the topic for us today.
Sure. Thanks, Brian. Welcome, everybody. So what we're going to talk about today is future-proofing network management. What we've seen, and I'll go into this as we go through the slides, is some massive changes in the way that we build and deploy networks over the last few years. And that's had a corresponding knock-on effect on how we manage and monitor those network environments. So we'll cover off this. The way we'll do this is I'll cover some topics and some points where we think things have changed and there's new requirements. And then what I'm going to do is, as we go through this, is hand over to Alec to actually show you. So we'll try and make this a show rather than tell session. So in terms of what's changed in network performance management, or what's changed in the network environment, I guess there's a number of things that have, particularly over the last 5 years or so, have changed completely and changed the way that we build network connectivity. The first one is a shift to hybrid cloud, and also a use of SaaS rather than on-prem based applications. And what we've seen with that is a number of things. One is that your users, as it were, whether it's customers or employees, are inherently distributed. So the internet has become the LAN to a certain extent. The other thing that we've seen is a massive change in the nature of network traffic, with a lot more kind of east-west rather than north-south traffic, particularly as applications get deployed either partially or in whole into a kind of a hybrid cloud environment. The second trend we've seen is a change from pretty static network environments to increasingly dynamic. The first phase of that were things like software-defined environments like Cisco ACI. Then that moved into the WAN with things like Viptela, Versa, etc. And we're seeing that continue. How we deploy connectivity into hybrid cloud environments is increasingly both defined through a software control plane, and also in some cases delivered by network elements that are software-based rather than run hardware, and that's had an impact on monitoring. The third trend is a real struggle in environments trying to hire network technologists. A combination of the change of technology and a genuine labor shortage in network skill sets has kind of meant that there's a real challenge in getting NetOps talent. So and I'll touch on that at the end as to some of the ways that we help to address that. And then the last two here are a move towards application rather than connectivity centricity. So in the past, we monitored environments based on, an application sat on a physical server. That physical server had a set of connectivity, a set of network connections that it was using. As we've distributed applications and moved them into both in the cloud and on-prem, that connectivity has changed completely. So the way that we need to monitor has changed. And then finally, a move from wired to wireless. So, Wi-Fi, I think, is now ubiquitous. As we came back to the office, there's no wired connections. It's all on Wi-Fi. I'm on Wi-Fi right now. And we see that expanding as we look at things like technologies like private 5G and an evolution in that domain. So in terms of network monitoring, to kind of drill this down another layer, there's kind of 5 areas where we see legacy systems struggle. One is breadth of collection, being able to collect metrics from multiple different technologies using multiple different APIs and collection mechanisms. Being able to do that at high frequency as well is becoming increasingly important. Driving automated insights or automated analytics on the data. Fixed thresholds some would argue, have never really worked, but certainly in these dynamic environments, they just don't work. So being able to know what's normal for a given time of day of week, and react accordingly. Being able to visualize the data in a much more advanced way. So typically the way that legacy systems have tended to work is the visualization is tied to the collection. And actually, in a modern sense, what we're going to be able to do is, regardless of how the data is collected or what format it is to be able to create views of that data that combine multiple different data sources. And Alec will show you this in action. Being able to automate actions. I mentioned earlier about a shortage of skills and a shortage of resources in the network domain. The only way that we're going to get around that is to drive automation. So rather than depending on humans to make decisions and take actions, whether that's at the moment kind of more process-based automation, in the future it may be dependent on AI and other analytics, but building that platform for automation. And then finally the depth of integration. One of the things we've seen, particularly in virtual network environments, is that it's not just SNMP anymore. It's being able to integrate, data from APIs, being able to pull metadata, being able to, the multiple different data sources and integrate that really, really quickly. And then finally, in terms of the IBM perspective on this, we've been a trusted brand in this area for, in the area of IT for more than a century, and in the area of kind of the network and the network monitoring space for probably more than 30 years at this point. And everything we do is underpinned by delivering trustworthy solutions in this domain and in every other domain that IBM work in. To give you a view of what we bring to market within the SEV1 solution, we provide complete network visibility, being able to support, multiple vendors. We've had an approach to vendor support that has included a 10-day device certification since our inception. And we continue to do that and continue to expand to support new vendors. Being able to provide machine learning-based analytics. So every metric that we collect is baselined in our terms, i.e., we're building up a picture of what is normal for that particular metric, regardless of where we sourced it from. Then, being able to visualize this, and Alec will come on and show this in a bit more detail, rather than me talking about it in the slides. And then finally, being able to drive, like I say, automated actions off the back of this. So, being able to have built-in workflows that you can very, very quickly deploy. To view this another way, you can kind of see this kind of moving kind of left to right, regardless of the technology, being able to collect that data using whatever collection mechanism is available, whether it's poll data, kind of metrics, file-based collection, etc. Providing the analytics within the platform, but then probably more importantly, on the right-hand side of this diagram is being able to make that data available to other OSS, other or enterprise management solutions. Whether that's automatically creating trouble tickets in your service desk, being able to provide SLA reporting in the context of if a managed service provider, or even internal reporting, being able to provide capacity and information into other systems for subsequent use. So that ease of integration into the overall OSS. So at this point, I'll hand over to Alec to basically show you some of this functionality in action. Alec, over to you.
Fantastic. Thank you, Tom.
There we go.
Welcome, everybody, to our demonstration. I join you here from my office full of rich mahogany, as you can see. So what I'd like to do is kind of touch on some of the big ticket items that Tom had just talked about that really makes SEV1 unique. The things that really make SEV1 SEV1, and the things that really allows you guys to effectively bring your infrastructure monitoring up to the next level. So Tom had touched on a couple items in that slide. The ability to collect data from any vendor, the ability to easily visualize that, the ability to ultimately get to a root cause quickly. And it really all revolves around the way that SEV1 is architected and the way that we can access these data sets. So if you think about your environment and you're having a situation or you want to understand what data sets you have, realistically, you want to go to a place that contains all of your data and can easily be accessible. And that's really what this visualization engine from IBM SEV1 provides here, is the ability to quickly access all of my data from all of my devices, regardless of location, regardless of manufacturer. So this page here is actually a page that we give you out of the box. This is our network performance report. And the idea here is that this is a place that I can go and get all the data for all of my devices. But that's a lot of information. That's a lot of data, right? So how do I get to what I want to get to quickly? And this is really where one of the magic components or one of the pillars of SEV1 comes into play, which is our ability to quickly and easily sort data sets on the fly without having to build hundreds or thousands of reports. And it has to do with our concept of grouping. So this report is showing me all of the alarms and all of the alerts for every device in my network. But I may only want to understand it for a particular geo as an example. So if I came in and typed in site as an example, I now have the ability to quickly and instantaneously sort this report just by my United States locations. And now this report automatically has been updated to just contain those data sets. So the days of having to build a North American report, a Chicago report, a Dallas report are gone. This report in real time visualizes the data sets that I want and need without having to go ahead and build multiple reports. And these groups can be created automatically using things like regular expressions or APIs so that you don't have to maintain this stuff kind of manually. So if I, as an example, have an issue and I know that I want to concentrate particularly on my priority 1 devices, I can come up here and just say, just show me my priority 1 devices. I've now gone ahead and filtered this down to just show me what we would call our P1 devices. Now my alerts table is specific to the thing I'm looking for. So now I'm instantaneously looking at what I need. I can see that I have 62 alarms and alerts. It's broken down by device, by location. But I can also see things that are really important, like what alarms we had and why they were triggered. And this really comes into one of the key components of what makes SEV1 unique and what allows us to be globally relevant, is our ability to use machine learning to understand what is normal inside your environment and basically proactively notify you of issues before they become major problems. Nobody wants to have to be digging through logs and trying to figure out what the heck has gone wrong way after an event. My joke that I like to use is I want to know that there's smoke in my kitchen long before my house burns down. So what we're able to do is take the historical data we've collected and go ahead and create a baseline, a normality curve for what we expect to see, not for just device by device, not just by poll point by poll point, but historically we can use this baseline to understand what I expect to see at a particular period of time for a particular day for a particular metric. So that means on a Monday, your data set is going to look different than it does on a Sunday. And to SEV1, we're keeping and retaining all of that data to build out this normality curve. So we can use that historical data that we have and the machine learning inside SEV1 to say, okay, we're looking at the current number of connections you have on a firewall. Well, we can see that the normal number is X. We drop below 50% of what is normal for that period of time. Oh, and by the way, you've created a complex alarm alert, which requires two components to be notified. So now what I'm seeing is, okay, I have an alarm where I have the number of connections that are currently connected has dropped below the average over a certain period of time. So long gone are the days of, well, 90% is fine, we'll just make it 90%. Our alarms and our alerts are tailored to what is normal for that metric at that exact period of time. So when I get an issue like this, I can say, okay, wow, my firewall connections, this is an alert. I got to figure out what the heck is going on here. I want to investigate this further. Well, it's really simple inside our platform. I can just come over to these words that are highlighted blue, click on the name and say, okay, Sev1, you know that this is both a network device, it's a device, but it also happens to be a Cisco ASA device. I want more information about this individual device. With one click, I've now automatically taken the data from the previous report and put it into this second report here, utilizing that alarm that we had. So now this template, we call this nesting doll feature, the ability for us to go from one report to the next. Now I'm visualizing the data set that I specifically want to drill down into without having to find the report, build the report. Sev1 is smart enough and creative enough to get you what you need on the fly in a troubleshooting situation. So now I have all of the data just for my particular firewall, right? So now I'm in real time investigating a problem without having to do digging, building, any of that stuff. It's all in front of me. So what we're getting at is the ability to quickly get to data sets and problems when needed. So if I want to look at what this issue was, which is the number of connections, I can look at this report and now say, okay, wow, I can see that I've had drops in connections. Well, let's use the data sets that are available in these tabs to help figure out what these drops in connections could be. Logically, the first thing I thought of was, let's take a look at something like CPU. That's going to be utilization of something, right? I've now gone from one individual metric to another individual metric with one click. In no way are the number of connections on a VPN associated with my CPU data. However, I, as the user, get to build and access these data sets as I want on the fly based upon what my use cases are. We as Sev1 will always give you best practices, but this is a quick and easy way to get the data sets that I want. If I wanted to visualize the number of CPU connections with, let's say, the number of CPU utilization with the number of firewall connections, as an example, I can quickly come in here and say, okay, you know what? I know this has nothing to do with each other, but let's go ahead and overlay the number of connections alongside my CPU utilization. Well, I've just gone ahead and taken two very independent metrics and put them on top of a single report. Well, now I can see very clearly that the number of connections is very much correlated to the CPU utilization. What I've just done is realistically taken two independent metrics that would be very difficult to show on the same report and visualize them together in a play that now provides value. This alone should provide a ton of value, but we can even go a step further, where I can then take these data sets and say, okay, well, what causes increases in CPU? Processes. So now what I have is another tab that is specifically showing me data sets for individual processes. So I've gone from VPN connections to CPU utilization to processes, all in one report, all in one tab, with the ability to correlate all these data sets together. If I want to understand which particular process is using the most CPU, I can quickly sort these. This dashboard here is really a great visualization of how our network is designed. This report on the left-hand side here is what we call a top-end report. For those of you that are of my age and like David Letterman, I like to call this David Letterman's top 10 list. This is always going to show me the top X number of data sets in a particular case here. This is an average of data over a period of time. The report on the right-hand side is showing me every single pull point that comprises that average. So now I'm getting an average value, but averages are liars. So now what I'm also getting is the ability to see every single pull point that comprises that average. And you can see that averages are liars because if we look at this, we can see the average is 7.56. But if we look at the report on the right-hand side, we can see that we have massive spikes in individual processing, which in this case happens to be our SSL. So if I unselect all these processes and just select my SSL, I'm now looking at a real-time report for just this individual processing. I don't have to build another report. I don't have to access anything different. I'm now looking at all my data sets. And you can now see this massive spike that correlates along with this massive average. Say I want to understand more about this data set. Yeah, this is great. What you're showing me is a bunch of data on a report. That's fantastic. But how do I get to the root problem? Well, That's where we can pull back in and look at the machine learning and the baselining that is part of this platform. And this is what I've referenced earlier, which is our ability to take the data sets you're collecting and provide you context as to what is normal so I can be proactive about what I do in my environment. So if we look at this report here, and I highlight over this particular metric, we're looking at CPU as an example. The solid blue line is the value that we have right now. The baseline is what is normal for that individual metric at that specific period of time. You can see that's roughly 20.34. And now this is really where the magic comes into play. Directly below that is the standard deviation. This is the acceptable range off normal that the administrator is comfortable with before we begin to alarm and alert off individual metrics. So this is really a great representation of what SEV1 can provide you. And this is for any metric in your environment. So if you have P1 devices, critical devices, you may not want as much deviation off what is normal than you might with your P2 or your P3 devices. I can build an alert policy that corresponds to a particular group of devices or metrics. So if I have a P1 group, I can say, okay, these are really critical to me. So I want to be notified if I deviate by 1 standard deviation, 22%, 2 delta points, whatever it might be, I want to be notified. But my P2 devices are a little less critical. So they can be about 2 standard deviations or 50%. We're okay with that. So I can control the alarming and the alerting for multiple data sets and multiple devices with one alert policy because I'm applying it to one specific group. And as I had mentioned, those groups can be automatically created using things like the REST API or regular expressions. So what we've really given you here is the ability to visualize large aspects of data, but at the same time, future-proof a situation where as I'm moving devices or metrics around my environment, I can quickly and easily have my alert policies automatically update, my reports automatically update, and to be rest assured that we're always building this baseline and we're always giving you something that we can alert off of and visualize off of. Because now somebody like myself who might not know anything about this firewall, I can look at this metric and know immediately that this data set is not okay. The normal value is usually X. The administrator had determined we're allowed to be between Y and Z for an acceptable range of deviation. And this is done for every metric, for everything we have. So when you think about how you can monitor your infrastructure and some of the things that Tom had touched on, the ability to future-proof your environment with a lack or a decreasing in knowledge base for users inside the infrastructure, SEV1 is giving you the ability to teach quickly and easily somebody, I don't know anything about this firewall, but I know if I look at this report that particularly that this data set is not okay because this is what's normal and this is what's allowed. And now we can go take this data and actually jump in and begin to troubleshoot because now I know that we have a particular issue around connections and that's something to do with the CPU utilization and processes. But what I really want to help understand is what is going over these VPN connections? What traffic is coming over this VPN? Because now we want to be able to correlate what causes an increase in CPU and what causes an increase in SSL processes. Well, simply because I'm a network engineer and I know my environment, I know that traditionally that could be something along the lines of a DDoS attack. But there's really only one way to prove a DDoS attack, which is to actually look at the application or the flow traffic that's passing over these individual interfaces. And this is really where one of the big components of the SEV1 platform comes into play, which is our ability to stitch application flow with metric data. We like to call this metric to flow. Our ability to visualize actual traffic going over an interface with what's transversing over that interface in one report and one easy place to go. And it's very easy to get to those data points. You'll notice in the upper right-hand corner here, I just have a plus button. Well, I can come in here and click flow. And now what I'm going to get is the ability to understand which individual flow metrics or what applications are going over this interface. With one click, I've now generated an application flow report that shows me what's going over these VPN connections. So when you utilize SEV1, we collect both metric and application flow data in a single place, which means I can correlate that in a single spot, which gives me the ability to visualize that stuff. So if I look at this report, I can see that when I have a massive drop in connections, I do have that large increase in SYN packets that are traditionally associated with DDoS attacks. So this is a little bit of a canned situation to give you guys kind of a look at the feel of what goes on with the platform. But think about the ability to access these data sets. Nothing I did here required me to go and build a report. The SEV1 system can easily pass data from one report to the next. These tabs are all very easy to navigate through. They all correlate with these filters at the top of the page. So when you think about what is available for a vendor agnostic platform with the ability to automate decisions, with the ability to do machine learning and visualize that stuff, I can take this report. These URLs are dynamic. I can take it off, email it to a user, put it in a ServiceNow ticket. We even have the ability to have ServiceNow tickets automatically generated when alarms and alerts are triggered. So this platform gives you the ability to quickly access multi-vendor data from whether we collect with SNMP or API, the ability to quickly visualize all of this in a really quick and slick way to get you to your mean time to resolution very quickly, and at the same time provide the skills that your team might need to understand and troubleshoot these issues without having to have 5 or 6 network engineers that know every single thing about your environment. The system can be future-proofed, it learns what's normal, and it notifies you proactively so that we can get to the bottom of things before my burnt toast becomes your insurance claim. So Tom, I will pass that back to you.
Thanks, Alec. Appreciate that. So I think there was we had a question as you were going through that regarding the alerting, and I'll paraphrase, but it was basically rather than showing raw individual alerts, can we alert at a service offering level? So I think there's a number of ways that we approach that. Being able to aggregate alarms up to a service level. Within the SEV1 platform, there's 2 capabilities you can bring to bear on that. One is creating or defining, if you like, we term them synthetic indicators or group indicators. So you can create new metrics based on the data that's being collected. So in some cases, we've had customers that create, if you like, a health index for a particular service based on the underlying metrics. So not only can they alert on it, but they can also see how it's trending over time. In some cases, that's used for SLA reporting. The second mechanism, which I'll touch on a little bit later in the deck, is using the automation capability we've got to think of it as post-processing of the alerts that we're producing. And then the third option in an IBM context is one of our sister products, as it were, within IBM is our Cloud Pak for AIOps capability, which has got AI-based event correlation, impact analysis, all that kind of very much with an SRE view on it, built in not just for SEV1 data or for network data, but for whether it's data that's coming from logs or from Kubernetes deployments or whatever, very much multi-vendor deployments. So there's kind of 3 options in terms of addressing that question. Hopefully that addresses that. So to move on, so what Alec went through, if you like, was some of what we would consider the kind of fundamental capabilities of the product. But what we've seen is, and even that in itself is pretty impressive for most of our customers and prospects. But what we've seen is new requirements that are coming out of the environment. So as organizations are deploying I'll take the first phase, if you like, of this, which is SD-WAN. So we started to see customers deploy SD-WAN based, replacing MPLS with SD-WAN probably 5-6 years ago. So how do we address those environments? Well, we had we had the ability to visualize the SD-WAN connectivity and manage it from a service perspective. So there's automated kind of policy and analytics that we've built in. We're also leveraging both packet level data as well as metric instrumentation to manage these environments. Discovering the topology, if you will, of the SD-WAN from the controllers. And then the other fundamental kind of key point is we support multiple vendors. So we've got a number of customers that for various reasons, either because of supporting different services or through acquisitions, have ended up with a multi-vendor SD-WAN environment, and being able to build a single view of that environment is pretty important to them. The next trend that we've seen is this move to hybrid cloud. So, at the bottom of this diagram on the right-hand side, you can kind of see the on-prem network infrastructure, which is typically what most tools manage. But then as organizations have started to deploy into cloud, they create increasingly complex, cloud network or VPC environments with cloud networking components, whether it's firewalls or gateways, load balancers, etc. And then, what we've done recently within the SevOne platform is not extended our visibility into that cloud world, if you like, the top of the diagram on the right. Why is that important in terms of extending visibility? Well, you can get metrics from, if you're in AWS or Azure, you can use CloudWatch or other mechanisms to get metrics from the cloud. But how do you correlate it back together with what you're doing on-prem? Because these environments are changing and migrating. And, the typical use case or use cases, primary use cases, if you will, that we see in this kind of environment is, first and foremost, hybrid and multi-cloud monitoring, being able to if you ultimately manage an SLA, both for a service that spans both on-prem and cloud. Tracking migration status is a key one. So looking at traffic, for example, to see, are there parts of the application that we've left behind? Seems like an obvious one. And then being able to right-size the environment. So one of the things that we do within the product is looking at capacity planning and capacity management. So being able to right-size your environment. And there's more use cases around this. I'm not going to go into these in detail, but we're expanding these as we go forward and see more customers start to look at how they monitor cloud network environments, whether that's dedicated connections, pure cloud infrastructure, working through a colo where they've got a cloud aggregation or cloud aggregated infrastructure in the middle of that environment. Then the next kind of topic, if you like, in terms of the difference between the kind of your legacy NPM and what's required today, is what we term as being able to speak app, and I've used air quotes in there. So one of the challenges that we've seen, particularly as organizations start to deploy workloads into hybrid cloud, but also increasingly use SaaS-based services, is they'll pose the question of, well, how's WebEx running? Or why is my Salesforce response time so bad today? And in the past, where, if that were an on-prem application, you knew the server it sat on, that server was connected to a set of network ports, you could very quickly go to that specific network device, look at that specific connection and see what's going on. Now you can't do that. So being able to bring an application level perspective to the data you're collecting and start with the application question and then drill down to the underlying network environment. The type of information and capability that's required to do this, and I don't intend to go through this slide in any great detail, but being able to support multiple vendors, being able to leverage data without deploying probes, for example, building workflows into the application, into our monitoring application that are application dependent, doing this in real time, all of those kind of things. So that view of being able to put a very application-centric lens on network infrastructure is something that we see of increasing importance to customers. And again, one of the things that this new multi-cloud world absolutely requires, because you don't know where the application is. You don't know whether, for example, if you take a SaaS-based application, you really don't know whether that application at this point is being delivered from Berlin or London, unless it's geofenced to a particular location. So that introduces a set of challenges around that. So what I'd like to do at this point, having kind of set that scene, is again, I'm going to hand back to Alec to kind of demo and walk you through how we approach some of this, in particular the kind of application centric monitoring. Because, like I say, I think showing is better than telling in this instance. So, Alec, back to you.
Thank you, Tom. Just when I thought I was out, you pulled me back in. So what I'm going to do is kind of approach this from the different sides. So the first demonstration that we walked through was very metric oriented, right? And I think it is important, right, to understand that we as IBM Sev1 realize that, it is an application world that we live in now. Applications are very important. So a lot of what we hear is WebEx isn't working. Why isn't WebEx working? Or not so much my gigabit Ethernet link is having jitter problems, because no one really thinks of your infrastructure that way. So what we've really done is we've taken the opportunity to then kind of look at this from a different perspective. So I showed you guys previously the ability to go from things like metrics to flow. Well, now what we have the ability to do is look at particular applications and components of our infrastructure and understand how the network is affecting those applications. So if you look at a report like this report is designed to really show me the top applications that are going through my infrastructure. And a lot of these are probably very common, things that you guys see on a day-to-day basis, right? Things like WebEx, YouTube, Dropbox. If it's March Madness, I'm sure it would never be TNT or TBS, but we all have worked in an office. So the ability to really understand where this application traffic is going is really important. So what we've really started to do is, just as Tom had mentioned, the ability to segment our application traffic out of our flow traffic. So I just do want to highlight kind of some of the base builds of this, is that we as IBM Sev1 are what we call flow agnostic. So what we're doing is we're collecting the actual application flow that's coming over your network and infrastructure. And it does not matter who the vendor is, whether it's NetFlow, SFlow, JFlow, IPFix, NVAR2, whatever might come out of the woodwork later. We are a vendor agnostic tool the way we collect these. So as you begin to change your network or your infrastructure, the nice part is that you don't have to worry about changing your monitoring tool. So if I want to look at a particular component of my infrastructure, I can actually come over here and I'm just going to isolate WebEx. And just like I had done on the previous reports, now what's going to happen is we're going to go ahead and isolate specific components of my infrastructure. So instead of looking at all of the applications and all of the flow for all of my things, I now can isolate individual application, which now breaks out the application endpoint names and the top clients. We also can visualize this a different way in what we like to call a Sankey diagram. And I'm very much a visual learner. So I think it's important that I show you guys all of the available options, which is, this is the logical representation of the traffic passing from the application IP down to the client IP. So just like we can do with anything else, we can filter this down and follow an application as it moves through these components, right? So if I isolate just WebEx, I can see the application names and the endpoints and as they flow through my environment, right? So we as Sev1 give you the ability to isolate specific applications. I even can come in here and say, okay, you know what? I want to see the actual traffic that's going over these applications. And just like I had done metric to flow, I also have the ability to do flow to metric. So now what I can actually see is the amount of network traffic that is traversing these applications. So when somebody says WebEx is slow, what interfaces are supporting WebEx? Well, we have the ability to do that now. We can come in and isolate applications and then understand what underlying interfaces are representing those applications. So if we begin to, if you say that WebEx is having an issue, I will say, as somebody who has worked in the network, traditionally it always is, well, there's something wrong with the network. Well, now what you have the ability to do is actually isolate which individual interfaces are supporting that application. And what I have seen from most of my customers is that traditionally, when somebody is saying I'm having an issue with WebEx, what I have found is that we as Sev1 have already generated an alert for things like jitter or latency or packet loss on that link. And they're actually already actively being investigated, which I think is a really good proof point of by tackling it from both ends, you can still see that we are getting to that resolution as quickly as we can. You'd also be shocked how many times the problem with the application is not the network. And this is a great way for you to prove that the network is operating fine. So we can easily approach this from the web, WebEx isn't working. Well, what's wrong with the network? To we actually already knew there was an issue on this interface. We're rerouting the traffic to another interface so that you don't experience these issues anymore. We were on this, we're already working on it. Or, well, I pulled the network performance report from WebEx, and what I can see is that effectively the network is operating fine. So there's a lot of ways that we can tackle these application problems. We also have a cool way of looking at this through services, something else that Tom had touched on. So now I can look at this from an application perspective, or I can actually pull this down from a service level perspective. So again, just like I have with applications, I can look at something like a SaaS application, something like Skype for Business that lives on-prem and in the cloud. And I can use the actual application flow traffic that's passing through this to understand what interfaces, what kind of traffic, what the look and feel is for this individual application. And I think that's really important because one of the things that is very different about today's world that is different than, let's say, 5 years ago, is the fact that so many of these applications are both on-prem and in the cloud, or many of these applications are just cloud-based. And you do really need the ability to understand how this traffic is transversing this application. So what we've done here effectively is we've selected a service, and now what I can see is every interface that is utilizing this service. And now what we're actually looking from is a different perspective. Now we're looking at the individual gigabit Ethernet links, the amount of traffic that's passing through them, right? And just like I showed you previously in the other report, I can drill down into a report like this. Apologize, there's some WebEx lag going on here. And I can actually, again, look at the baseline capabilities of this individual metric, right? So now what I've done is I've gone the other way. I've looked at an application, I've looked at a service, I've understood what my most utilized interface is for that application. And now what I'm looking at is the traffic that is passing over that pole point by pole point, and I can see whether or not that traffic is normal. And what you can see is that this traffic stays inside this shaded line almost the entire way. So it is normal to see this kind of traffic. So this is really a huge benefit that I think can be provided from this network infrastructure level. The ability to effectively not only just have to dig through the network, which has value in many cases, but other times you'd have to work backwards to go forwards. Now it just makes sense to start with the application, which SEV1 is tagging and visualizing in this report as we've shown here, and then giving us access to the underlying data. So effectively you can have one of two answers of, well, I'm looking at all my applications. I can see the traffic passing through them. I can see that my applications are doing fine. Or I have a troubleshooting scenario. I need to understand why this application is not working. Well, we're already monitoring the underlying infrastructure. So that's really easy. We've already got proactive alarming and alerting on the underlying infrastructure. And or I can give you the ability to prove that the network is not your problem with the application. So it's two great tastes that taste great together, as they say. The ability to give you metrics and flows and metrics, depending on how you want to approach your application strategy. I'm in no way saying that SEV1 is going to be able to tell you how many widgets your application has made and whether it's made them properly. But what we do have the ability to visualize and show for you folks is how those applications are transversing your infrastructure and how your infrastructure is affecting those applications so that you can feel like in real time you understand how your applications are performing. Because now that we live in this app-centric world, understanding that I have 5 gigabit Ethernet links is not enough. I need to be able to understand that WebEx and YouTube and all these other things that are utilized are operating effectively. And that's really kind of where we transition to the other thing that Tom had mentioned, which is the ability for this multi-hybrid cloud monitoring capability. I had touched on it, something like Skype as an example, which is now an on-prem, a SaaS, and has many different flavors, and they all work together seamlessly, right? Well, I now need the ability to monitor things that live in the cloud. I need to be able to monitor things that live on-prem. But what I don't want is to have two different tools to do that. And that's effectively what the SEV1 platform can let you do. As you can see here, just as an example, this is using both IBM Cloud and AWS. We're monitoring, right? We also can monitor things like Azure, and all kinds of other good things, right? To understand what's going on with my AWS S3 as an example, or how my applications are performing in the cloud, right? I can come up here and just isolate AWS as an example. And now what I've done is even dug a little bit deeper. I'm now looking at each component of this AWS cloud where I can see, your west, your east, all this good stuff, right? I can monitor the traffic going in and out. And I think the big benefit here, the thing that I want to touch on is that I keep mentioning the baselining and the machine learning. It applies to every metric that comes into the SEV1 system, right? So we are baselining this data. We are building that normality curve. We are notifying you of deviations from normal so that I can look at these data sets and understand immediately, okay, is this traffic abnormal? Is this traffic normal, right? Just to expand our horizons back out here again, I mean, you can look at things like the interface traffic that's going over these. I want to understand, because AWS, or really any cloud, is very read-write heavy in terms of cost. I want to know which individual devices or which individual interfaces are passing that traffic back and forth for just cost reasons, right? Understanding the volumes as an example. And this is what I like to particularly show, which is the underlying metadata of this. And something that I haven't really touched on yet, which is our ability to supplement your data with things that might come out of your inventory management tool or wherever else you might keep those individual data sets. We as SEV1 do not care where the data comes from. We only care that it's valuable to you. So if you want to supplement your cloud metrics or your network metrics or your CPU metrics with latitude, longitude, with emails, with priority, with whatever you'd want to do, that is totally up to you, and that is totally allowed. So many customers utilize metadata from things like inventory management to then tag individual devices, for which we go back to the original thing that I touched on, which is for grouping and alarming and alerting, right? So there really is a lot of functionality in this platform. And I'm really only touching on a handful of things we can do in the cloud. But think about what is in front of you here. It's our ability to monitor the key components of your multi-cloud infrastructure, the ability to pull that data in, baseline it, normalize it, and alert upon it. And I still only have to go to one place to look at all this stuff. Everything I've shown you so far today, whether it's metrics, application flows, cloud monitoring, this has all been the same GUI, the single pane of glass. So really what you have is one-stop shopping for all of your visualization, all of your data analysis for your infrastructure, whether it's APIs, whether it's SNMP, whether it's IPSLA, we can go all up and down that route. But the idea here is that it's one single pane of glass that I've shown you that has application flow, network, cloud. And the benefit here is that this is all kept raw for a full year. All data collected by SEV1 is kept raw for 365 days if pulled at 5-minute intervals. So that means none of this data is averaged until it's for a full year, which means I can go back 180 days and see exactly what happened. I can use this for capacity planning, and I can use this for trending. So that really is kind of my spiel here, is that I intentionally worked with these folks to help break this up. But if you think about it, this is a single pane of glass that contains all of your data, regardless of where it lives, who makes it, and sort of whether it's old school technology or new and sort of adaptive technology. So that's my story. I'm sticking to it. Tom, I will pass it back to you.
Cool. Thank you, Alec. That's awesome. One question that came up in the chat as you were presenting there, and I guess I'll throw it back to you, because you can answer it better than I. And I'll paraphrase, but it's the flow analysis. How do we handle encrypted environments, I guess, is in summary, where traffic has been encrypted. Now, I know with things like HTTPS, we can still see inside. I'm guessing for VPN type connections is probably a different challenge.
Yeah, so what I would say is that obviously encryption is challenging, right? Ultimately, we as SEV1 are only going to be able to see what you send to us and what you let us see. If the data is fully encrypted and it comes to SEV1, really what we're doing when it comes to flow is we're looking for particular components and packets, right? That's what makes flow sort of unique. That's what makes SFlow, SFlow, JFlow, all that good stuff, right? So if your data is encrypted, you're still going to be sending us packets. Those packets can be tagged. We can build visualizations. Unfortunately, I don't have a silver bullet, this is how we would do it, because it really depends on who the vendor is and what the type of encryption is. But what I would say is that this platform is really flexible. And the fact that you can manually tag applications inside the system. So if you have an internal application or an encrypted application and you still want it to be visualized, even though it's encrypted, you can pick port ranges, you can pick, UDP, TCP, you can pick IP ranges, and then you can manually tag that to have that come up as an application. So we may not have to be able to see every single component that's piece of this flow. We may be able to work around it depending on what your level of encryption is. But my response would be, other than the long-winded answer, is that it would be a case-by-case basis, but there are many ways to get around that, is what I would like to say.
Yeah, cool. Thanks, Alec. So the final topic I wanted to touch on. So we talked about, kind of, if you like, I'll say basic, even though it's not basic, but the kind of basic performance monitoring capability across the multi-vendor network. In kind of the first demo, we then extended it the second time and talked about both being able to view the environment through the lens of an application and what that entails from a network perspective, and also in the context of multi-cloud. So being able to do that application centricity across multi-cloud with a range of underlying connectivity. So I hope that the capability of the platform has kind of come out as we've gone through that, and particularly as Alec has demonstrated it. But then the final topic, and I alluded to this earlier, where pretty much every organization we work with are constrained in terms of operational resources, and that constraint is coming from a number of directions. One is the environment is inherently getting more complex. As I support multiple clouds, as I deploy workload into multiple different environments, then I've got N times the number of technologies I need to become familiar with. Cloud networking in particular, what we're finding as we talk to customers is you take somebody who is certified on Cisco or Juniper or another vendor's product. They have to go through an entire new set of certification on AWS, and it's different for Azure and it's different for Google. So there's a new set of skills, and like I said, a lot of our customers and organizations are multi-cloud and multi-vendor. So the way that they're trying to get around this, and the way people have been trying to do this for a while, is introduce automation. So what we added recently to the SEV1 capability was a low-code, no-code automation framework. So there's a couple of things it does, and I've just got one slide on this today because we will be doing a follow-up webinar on rapid network automation, as we're calling it. But the first thing is, because it's low-code and no-code, instead of writing scripts, and people have been writing scripts, whether it's Expect or Perl or whatever, for forever in this world. But that requires a specific set of skills. So instead of doing that, allow you to drag and drop and build automated workflows through a UI, essentially. So democratizes that automation capability. The other thing that enables is you can amplify your existing automation. So if somebody's written a really cool Ansible script, or they've already got a deployment planned in Terraform, or they've written a PHP routine that does something particular, you can reuse that, pull it into this framework where it kind of becomes self-documenting. So you can see where it fits in the workflow, what it's actually doing. And then what we're doing as a vendor in this respect is we certify, if you will, if you're familiar with SEV1 in the past, where we certified devices, what we're doing with automation is certifying APIs. So, a customer comes to us and said, I need to integrate with, vendor X, whatever that vendor is. We'll add the API, take the API calls and functions, encode them, if you like, or surface them as building blocks that you can then drag and drop to create those automations. There's multiple use cases. I would point you at the IBM community, community.ibm.com. And if you search on SEV1 or network automation. There are a number of automation workflows and templates that have been built by us and our customers that are published and are free to use. It will both give you an example of what's possible with the platform, give you some ideas, and give you some insight into what's possible, what you can do with it. But like I say, we're going to be doing a separate webinar on just this topic in the future. Hopefully, what I've covered today in terms of the reason you would want to reevaluate your legacy network performance monitoring system and hopefully consider SEV1. Hopefully, both the rationale and what we bring to the party, as it were, has come across as we've gone through these kind of slides and demos. Thanks to Alec for supporting me on this. I certainly couldn't do this on my own. And with that in mind, I'll hand back to Brian to bring us home.
Okay. Well, again, Tom, Alec, thanks for walking everyone through this today. And I echo Tom what you're saying. I think as folks out there who day to day are managing and monitoring networks, going through rapid change and trying to keep on top of what's happening out there, it really is a movement toward understanding what's normal and what's not. Right? It's not a matter of trying to watch everything. It's looking for those exceptions. And some of the demonstrations that Alex showed off today of having a system that looks for what's normal and what's not, and raise the awareness of the situations, and the ability to, with some of the questions we got today around the ability to customize and add in synthetic indicators, right, to help understand what's happening across a range of indicators and trend those as well, right, just gives extra levels of capability for you to have the insight you need at your fingertips, right, to keep on top of performance of your network. I know we do have a couple more minutes. If there's any more questions, I'll give it a few seconds here to see if any do pop up. But if those don't come in, feel free to reach out to the team at here at IBM.com. Just if you do a search on IBM.com SEV1, you'll jump right to the SEV1 homepage, and be happy to answer any questions as you come through there. So I think with that, we're getting here toward the top of the hour. So I think we'll sign up for now. Everyone, thanks for joining in, and we'll catch you on the next webinar.